All right, welcome back, everybody. We're going to start week 5 by putting together everything you've learned so far in trigonometry. So that's SOHCAHTOA, sine law, cosine law. And now get questions where we have to decide what formula to use in each situation. So today's lesson's not very long, but you're going to spend your week doing review, and the questions will be mixed. So it won't just be a cosine law section or just a sine law section. So in each question, you're going to have to ask yourself, what is the question giving me, and what am I supposed to use in order to solve for the missing amount? So you have to do that each and every time now with trigonometry. So that's what I'm going to show you today, is how to make those decisions as to what to use in each case. So the lesson today is only a couple of questions, and I'm going to show you how to decide what formula to use. You're going to find your homework in, of course, the worksheet section, 2.8. There's 4 questions there that I'd like you to do, 1, 6, 8, and 10. And then the next section, which is called Unit 2 Review, it's called section 2.9. There's some questions there that are, again, from the whole unit that I'd like you to do. And of course, your solutions are there as well. By Wednesday of this week, I want you to come back to D2L, because you should be done this work by about Wednesday, Thursday. Come back to D2L and I will post your assessment. So your unit quiz, your quest, your unit test, whatever you want to call it, your unit assignment, because after this we are done trigonometry and we're going to move on to our next unit for next week. So I want to give you an opportunity to earn some more marks. And this is when we're going to do it. So I won't post it until after this is done. So you should expect it by Wednesday or so of this week. So just come to D2L and I'll post it like an assignment bin on the main screen in the activity feed, and you'll just be able to do the work from there. All right, so let's get started. So again, go to your lesson section and you're going to see 2 questions listed here. It's only 2 questions. But I want to, before we get into that, I'm going to show you how to decide what formula to use. So this is just a plain sheet of paper, and I'm going to go through what I call the decision-making tree for trig. So this is your trig decision chart. Okay, so this is what you need to ask yourself each and every time you do a trig question. And we're going to do it like a flow diagram. The first question you need to ask yourself, so Q for question, you're going to ask yourself, does the triangle have 90 degrees? Okay, so that's the first thing you need to ask yourself. So that could be a tree kind of question, a ladder leaning up against a wall kind of question, a person standing. Those are all assumed to be 90-degree angles. So you're either going to get a yes answer or a no answer. If it's a yes answer, then what that means is that you're allowed to use SOHCAHTOA. And that's what you should use, because that's quick. So remember that sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. So that's what you're allowed to use if there happens to be a 90-degree angle in the triangle. You are also allowed to use Pythagorean theorem. So that's your a squared b squared equals c squared stuff. Remember, that only works in 90-degree triangles. So of course that's allowable as well. However, if the answer was no, if you had some kind of random triangle that looked like this, and maybe this was, I don't know, 70 degrees, so you don't know that there's a 90-degree angle here, and you definitely don't think there's a 90-degree angle there, in that particular case, then the answer is no. So then you need to ask yourself the next question. And the next question is going to be, do you have a complete angle side ratio? So that means, do you know an angle and a side in a triangle? So that would mean the 70 and maybe 15 centimeters or so across from it. Do you have one of those situations where you have the angle and its corresponding side? And again, your only choices are yes or no. Either you know it, or you can find it, or you have no idea, and there's no way you're going to be able to get an angle and side ratio. But if it happens to be yes, like it is here in this diagram, then you know it's a sine law situation. You're allowed and you're supposed to use sine law. So what does that mean? That means that we set up sine law depending on what we're looking for. So remember, in sine law, if you're looking for the sides, you put the sides on top. If you're looking for the angles, then you just flip the ratio and you put the angles on top. And the order you write it in, A, B, B, A, that doesn't matter. Okay, so again, if you're looking for sides, you put the sides on top. If you're looking for an angle in the situation, you put the angles on top. But remember, you can only use sine law if you have a complete angle-side ratio. Now, if the answer was no, you didn't have a complete angle-side ratio, then that means you're going to have to check to see that if you have a side, side, side situation, which means you only know 3 sides, so 10, 11, and 12, but no angles, or is it a side angle side situation, where you have a 10, an 11, and a 60 degrees, say, in the middle. That's an SAS situation. If it's either of those two situations, then it's definitely cosine law. So cosine law is your last resort. So in cosine law, you have to set it up depending on if you're looking for sides or angles. If you're looking for sides, you set it up with, again, the side and the front, whatever it is that you're looking for, and the other 2 sides squared and added together. The order you write it in does not matter. And then we subtract 2 times B times C times the cosine of angle A. Now, that's if you're looking for a side. If I'm looking for the angle, I put the correct side in the front that matches the angle that I want. And remember that I showed you how to rearrange it by bringing things over to the other side. So we would get something like that. So we bring over the b squared, we bring over the c squared, and we divide by negative 2bc, and that's how you get cosine A all alone. So basically, this is your chart as to what do you use and in which situation do you use it. So we're going to go through these next questions right now using that decision-making chart in order to answer these questions. Now notice at the start it's saying don't forget about. So don't forget about SOHCAHTOA. Don't forget about Pythagorean theorem. Because those are quick ways of getting your answers, right? Not every question is sine law or cosine law. Okay, so it's important that you go for the most efficient and effective formula, and you don't automatically assume it's a sine law situation. Sine law will work in 90-degree triangles, but that's not the best thing to use. So it's important that you always look for what's the best thing. So she is flying his kite. The kite has a string that is 40 meters long. The angle of elevation that it makes, again with the horizontal, remember angle of elevation is always from the straight line up. That angle of elevation is 26 degrees. What is the height of the kite? So first things first in this diagram, because they gave us the picture here, is we don't have a label diagram. So A, B, C. Next, it's saying what is the height? Height is vertical, right? Straight up and down. This is height, AC. So let's put an H there to indicate that that's what we're looking for. So now our diagram is a little more complete. Now we're able to now go through our decision chart. First question, does the triangle have, so I have the decision chart right in front of me, does the triangle have 90 degrees? Well, yes, it does, because it's always a safe assumption when you're dealing with height that it makes a 90-degree angle. So it's not like you're making it up that that's 90 degrees. It is 90 degrees. So because it has a 90-degree angle, this is going to be a SOHCAHTOA situation. So the 26 degrees is what we use, and it dictates that the H side that we're interested in, is going to be, sorry, I'm just putting this closer like that. The H side is going to be considered opposite in this case. Is that better? That's a little bit better. So we have the opposite, and we have the 40. The 40 is across from the 90. That's the longest side in the triangle. That's considered to be the hypotenuse. So you go through your formulas. Is it sine, cos, or tan that has opposite and hypotenuse in it? OH. Well, OH is sine. So we're going to use sine theta in our formula equals opposite over hypotenuse. That's sine 26 degrees. The opposite is H. You could have used an X there if you wanted. You could have also called it little b because it's lowercase b in the diagram. All of that makes sense. It doesn't really matter. The hypotenuse is 40. You don't have to put the meters. Now to solve for H or X, which is the top, we bring up the 40 and we multiply on the other side. So pick up your calculator. Again, always make sure it's in degrees mode. Do sine 26 times 40. Oops. And you get 17.5 to 1 decimal place. So 17.5 equals H. So we look at this diagram. Could this side be 17.5? Does it make sense? Well, any number less than 40 makes sense because it has to be smaller than the hypotenuse. So the hypotenuse is 40. This side has to be a number smaller than 40, and this happens to be smaller than 40. Now, always make sure if the question came to you in words, like this one did, right? It was all written in words, that you respond back. Therefore, the height of the kite is 17.5, and then you go back to the diagram and you ask yourself, what are the units in the diagram? So it's meters according to the question. So that's where we stick meters right there. And because I'm not using this number for anything else, that tells me right then and there that I'm finished. I can round to 1 decimal place. Okay, so I didn't want you to use sine law in this situation because it wasn't necessary. We had a 90-degree angle. All right, let's do the second and last one just to show you again how to use and make decisions using the tree decision chart. It says 3 lights are located in a park along 3 different paths. The distance between the first light and the second light is 15. So light, and then make a path, and then you're going to go to the next light. I'll do LMN. The distance between the first light and the second light is 15 meters. So let's put 15 there. The distance between the second light and the third light, okay, so LMN is 19. Obviously, this isn't to scale because that should be longer than this, but that's okay. The distance between the first and the third light, so the beginning to the end, is 17. Calculate the angles between all the lights. So I need to know this angle, angle L. I need to know angle M, and I need to know angle N. So angle A, angle B, angle C. All 3 angles are missing. So this is our situation. This is our diagram. Again, we start with the decision chart. So do you have 90 degrees? Probably not. I can't assume that there's 90 degrees in that triangle. So I go the no way. The path I take is no. Do you have a complete angle and side? No, because I don't have any angles. So I have all the sides. I'm missing an angle. So that means it's not sine law. So this is definitely not a sine law situation. So that's a no. Do you have side, side, side or side, angle, side? Well, I have the side, side, side situation. So that means it's cosine law. So based on the decision-making chart, we're going to use cosine law. And we're going to use it to find angles. So this is the one that you rearrange. Let's try angle L. I just happened to pick this guy. So let's use that guy as our first guy that we're going to find, angle L. So for angle L dot dot. Remember when you set up cosine law, you set it up with the side that matches the angle you want in the front. So L squared equals m squared plus n squared minus 2mn cos L. Now some of you memorized the formula that's rearranged. I'm showing you each time where it comes from. So if you went straight to the memorized formula, that's fine. Bring the m squared over, it becomes subtract. Bring the n squared over, it becomes subtract. Divide by the negative, the 2, the m, and the n. And that's how you get cos L all alone. So now we're going to sub in our numbers. Little l is the 19. The 19 has to be in front of this formula, the way I've rearranged it. M is 17. N is 15, right? So right across from the vertex, N. Negative 2 times 17 times 15 on the bottom. And to save some space, I'm going to do inverse cos. I'm going to write it out at the same time, just to save myself some time and just give me angle L all alone. So in your calculator, figure out your numerator, write it down. Negative 153 on the top, and negative 2 times 17 times 15. Negative 510 on the bottom. You could inverse at this point, write the inverse here or there, it doesn't matter. It should be written though. So 153 divided by 510 equals, and then go shift cos, second function cos. Don't write the 0.3 down because that's not really important. I got 72.5 degrees. Sorry, not C, L. That's supposed to be an L. So angle L I got is 72.5 degrees in our corner there. So after you've done that, which was step 1, you now have to do step 2. And step 2 is find another angle. Your choices are, if you remember back to the lesson we did, you could reuse cosine law, do this all over again, and just pick one of the other 2 corners to start with. So m squared equals, or n squared equals. That would be fine, and that's actually safe because you're only using the numbers that were given in the diagram. Or you can decide now to use sine law because you have an angle and you have a side. And if you have an angle and a side combo, you're now okay to use sine law. You're just assuming and hoping that this last answer was correct. Because you're now going to use it in a future answer. So I'm going to do sine law just to show you that formula. So I'm going to set it up for angle M. So my new theta is going to be angle M. I'm looking for angles, so sine capital M over little m equals sine capital L over lowercase l. I don't know angle M. Little m happens to be 17. Capital L is 72.5. For angles, you don't need to keep all those decimal places because they're not sides. So 1 decimal place is fine for an angle. And lowercase l is 19. So because what I need is on top, I just have to bring up the 17, show my rearrangement, 17 times sine 72.5 all over 19. So in your calculator, you're going to go sine 72.5 times 17 divide by 19 is 0.85333, whatever that is, right? So that's what we're looking at right now in our calculator. I don't want to write all that down. You can, but I don't want to. So angle M, unfortunately, we're going to have to because I didn't put the inverse in front of all of that. 853325692. So again, do not round this. Do not call this 0.8 or 0.9. That would be incorrect. Go shift sign while it's all still in your calculator. And to 1 decimal place, 58.6 degrees. is what we get. The last thing we need to do, I'll put number 3 over here, is angle N. So this was 58.6 degrees. For angle N equals 180 minus 72.5 minus 58.6. So once you get 2, you automatically can use them to subtract from 180, 58.6, 48.9 degrees. So this one is 48.9. And again, always check at the end that your diagram makes sense. So 180 minus this gave me this. And of course, you always show your work because that's what I'm looking for. And again, it should be written like this. 180 minus the other 2, equal sign underneath, your final answer. So you should be writing yours the exact way that I'm writing mine. I'm looking for, what step did you do first? I'm looking for your formula. I'm looking for your substitution. I'm looking for your inverse. I'm looking for your equal signs. I'm looking for your symbols. I'm looking for your rounding. And step 2, formula, substitution, rearrangement, inverse in this case, and final answer. Final answer, right? I want you to go back, find the smallest side. Is it across the smallest angle? Yes. Find the biggest side. Is it across the biggest angle? Yes. And of course, the medium goes with the medium. So that's one way that you can use to check your answer to see if it makes sense. All right. So again, we did our decision-making chart to help you determine what to use when you're presented with a trig question. Is it sine law, cosine law, and so forth? So you just have to go through each case, what to use. And now you're going to do your work again on 2.8, 1, 6, 8, and 10. It's only a couple of questions there. And then 2.9, the Unit 2 review. I'd like you to do all the questions, 1, 2, 4, 7, 9, 12, 13, 15. Come back and check D2L by about Wednesday, maybe midday. I should have your assignment up. That'll act as your unit assessment for all of trigonometry, and it'll be very similar to what we're doing just here. All right, so if you have any questions, please again ask me. I'll go over any issues you might have. Remember, the answers are listed in each of those sections for the homework as well. All right, have a good week.